Okay, so what we're going to be looking at today is using our calculator, or specifically a graph, to help us in factoring a polynomial that doesn't necessarily seem like it can be factored any other way. And so a lot of this all comes back to this big idea that if we can find a zero of the function or an x-intercept of the function on our calculator, we should know the associated factor that goes along with that. And so we're going to start off with this first polynomial here. And just by looking at it, it looks kind of complicated. It doesn't follow any of our factoring patterns, and kind of really not knowing where to start. One thing we should know right off the bat, you should be able to look at our y-intercept and know that that should be 35. And by looking at that x to the fourth, we should know generally what the shape of the graph looks like and behavior of the graph, in other words. But exactly where the zeros are, we're not so sure. So to start off with, what we're going to do is just go ahead and graph that function. Now if we look at this graph, I don't know if any of you can see that or not. Nope. Yeah, there we go. You can kind of see that. So by looking at this graph, we can kind of start to see we've got a zero there, and its multiplicity is 2 because it bounces off, and we've got two other zeros there. That should be all four of them. So we can use our calculator to find these zeros, or we can look and say, well, that looks like it's at -1. That looks like about like a 5, and then that one looks like it's about at 7. And so based off of that, we have an idea of where we should start and what factors we should look for. So the first thing I want to do here is just go ahead and sketch this graph. Make this a little bit darker so you can read it. I'm going to sketch that graph really quick. And what I'm really looking for is the zeros. So I know I have a 0 at -1, 0 at 5, and a 0 at 7. And I also know my x-intercept up here at 35. And so it looks something like this. So the big thing with this is, just because our calculator makes it look like there's a 0 or an x-intercept at -1, 5, and 7, doesn't mean we should necessarily trust it. What we still want to do now is to actually go through and divide those out. Make sure that's actually what we get. This is where we really like synthetic division. So we'll start off with this. If x equals 1 or x equals -1 is a 0, we should know right away that we have a factor that goes along with that of x plus 1. And so what we're going to do is we're going to divide our polynomial by x plus 1. And to do that, I'm going to use synthetic division, which means if I'm dividing by x plus 1, I'm putting a -1 there. Whatever my 0 is actually going to end up right there. And so I'll use synthetic division. And what I'm looking for here is my remainder to be 0. If my remainder is 0, that means it's actually a factor. So I'll drop the 1 down, -1, add, multiply, add, 23, multiply, add, multiply, and add. And as you can see, we do get a remainder of 0. Now, rather than rewriting this out and then dividing again, I can just use these numbers. I know this x minus 1 has a multiplicity of 2, so I'm going to go ahead and divide it out again and see what I get once I divide it the second time. My remainder is going to move over a spot now. So I drop down the 1, -1, -12, multiply gives me 12, add gives me 35, multiply -35, and again I get my remainder of 0. And let's go ahead and do one more while we're at it. Here we have a 0 at x equals 5, which means we're trying to check for a factor of x minus 5. And so I'm going to divide x minus 5 by putting my 5 right there. And we'll go one more time and see what we get. Drop the 1 down, 5, that gives me 7, which is, -7, which is -35, and I get my 0. So you can see that one also worked. And if you take a look at what's left, this represents x minus 7, which is our last factor, and it gives us our 0 at x equals 7. So we know, now we actually have the math to prove it, that the x-intercepts are at -1, 5, and 7, that the factors are x plus 1, x plus 1, x minus 5, and x minus 7. And we've actually done the math to check it. We haven't just trusted our graph, and we've written that thing in factored form. And we could also rewrite it. I've got a spot down here for you. We could always rewrite this as x plus 1 squared times x minus 5 times x minus 7. But that's going to be factored form. We've proven that those are our zeros, and our calculator is able to help us out, but we still did the math to actually show that we knew what was going on. Now, if you look at the second page, the big difference here now is that not all the time are your zeros going to be really easy to find. And so in this one, when you actually go ahead and do the graph, go ahead and type that in really quick here.